Hi everyone. So welcome back to the second lecture of this week. In the first one we did talk about the typical wastewater systems and how there are various options available for the removal of different constituents or different type of pollutants present in the wastewater, and how we can actually pick the different units, unit processes or unit operations, and then put them in a sequence of flow for getting the treatment from the stage of a raw wastewater to the finally treated effluent. So, the conventional systems that are used, we did have a kind of refresh of the conventional activated sludge processes and conventional anaerobic system, which is USB. Predominantly USB systems are used as a conventional anaerobic treatment systems. So, we did have a kind of recap of those things in the previous class. So, this class we are going to talk about, again we are going to start the discussions on the approaches, newer approaches which derive the concept or removal mechanisms from the traditional physicochemical or biochemical principle and processes, but their assembly, their integration or their arrangements are different than the typical conventional treatment systems. So, these integrated systems we will be discussing from this class onwards throughout this week, and the first thing that we will be discussing in this particular lecture is the wetland systems. So, if we see the various treatment approaches, as we were saying, so the conventional wastewater treatment approaches that we have, we can have a deviations from those conventional treatment approaches which gives us some new assembly or new design or new approach for treating the wastewater. Now the basic principle and processes are still going to remain same, the basic physical processes, chemical processes or biological process will still be there. However, their selection and their integration in the system will be done in a different way from the conventional treatment systems, and this is done with an idea of either optimizing treatment efficiency or reducing cost, reducing energy consumption, reducing land requirement. Okay. So, whatever our objective is, or making the process simpler, reducing the technical expertise in operation and maintenance. So, whatever could be the objective, it is done with those objectives, and these treatment units are usually configured differently than the traditional treatment systems. Okay. So, there are usually more these type of systems are usually more applicable for decentralized stage treatment, however, it is not always. Okay. We have systems which work for a large scale operations as well, but still the majority of systems are used for a small scale municipal wastewater treatment or industrial effluent treatment systems. Okay. So, if we see some of these commonly used systems, they are natural or constructed wetlands, mostly the constructed wetlands, and then there are sequencing batch reactors, sequencing batch biofilm reactors, membrane bioreactors, moving bed bioreactors. So, these are some of the popular systems. Of course, there are other configurations available, and in addition there is lot of research and development going on. Okay. So, with this like development of new and new technologies, advent of newer technologies coming into the market, we are having various alternate reactor configurations available. However, these are the popular ones which we will be discussing in this week. So, to begin with, the wetland system is actually there are natural wetland systems and there are artificial wetland systems, which is also known as constructed wetland systems, or at times we call them engineered wetland systems or man-made wetland systems. So, essentially the natural wetland system, like in the scientific community or many expert consider these like kidneys of earth. So, we have our own kidney. What is the role of the kidney in our body? The role of the kidney is to filter the various toxicants and pollutants that are entering, that are there present in our body. Okay. So, that is the role of our kidney. So, similarly the wetlands may be considered as earth's kidneys because they filter the pollutant, they filter the various pollutant from the water that actually flows its way to the receiving lakes, streams, oceans or subsurface groundwaters, those kind of places. So, these wetland do this part of the kind of filtration of the pollutants, okay, and that is why like many people mark them as a kind of earth kidneys. Okay. So, what you see on a screen is it is basically a East Kolkata natural wetland, one of the largest natural wetlands across the globe, okay, and is like a significant part of the Kolkata's wastewater is lined to these wetlands where there is some degree of treatment takes place, and then this wastewater is reused for the purpose of like fish culture or those kind of thing. Okay. So, that is one of the examples of natural wetland systems. However, these natural wetland systems will have a limited capacity because we are not doing any alteration, we have no control over the flow rate, we have no control over the other aspect, and once we kind of allow the raw sewage to flow through this, so there is lot of contaminant in the sewage and there will be an assimilation capacity of these natural systems because we are not doing any intervention in this. So, there is a limited capacity of these systems, and over a period of time we may see that those capacities are exhausted, and as a result we may not see them doing this purification task or purification job. It is similar to like we discussed when we are discussing the natural attenuation of pollutants in the river or streams. So, we add contaminant to the river, it kind of undergoes self purification, but again there is a capacity of self purification as well. So, that it is not that possible that the self purification can go to the infinite scale. So, that way the capacity of natural wetland systems are also kind of fixed, and they cannot bear the excessive load of pollutants. For the purpose like taking this clue from the natural processes that happen in a natural wetland system, we can actually create an artificial wetlands, what we also call as the constructed wetland system. So, these are essentially engineered system which are constructed to replicate the processes or the functions that takes place in the natural wetland systems. Okay. So, whatever the processes that takes place in the natural wetland systems, we can kind of allocate some piece of the land and let develop in fashion where like similar to the wetland, all those processes which takes place in a natural wetland could take place in this constructed wetland as well, and probably with more control on that. So, these constructed wetland that way are actually the treatment systems which are designed and constructed for utilizing these natural processes which involves wetland vegetation, which involves soil, which involves microbial systems for the purpose of treating wastewater. Okay. So, that is what happens in the artificial or constructed wetland, which is a kind of system similar to the natural wetland system for the purpose of treating wastewater. So, what are the various processes that takes place in a wetland system? Well, there will be first thing there will be adsorption. So, it is a wetland system, there is soil through which water is passing, or there could be media in constructed wetland system through which water is passing. So, there will be adsorption takes place. So, on the soil minerals or on the kind of clay particles whatsoever is there, or the media that we are putting through will absorb some of the contaminants present in the water. There will be filtration taking place. So, normal straining, it has to pass through the various pore sizes available in the soil, the water has to pass through that, and if the contaminant particularly the suspended impurities are of size larger than the pore sizes, they will get retained, they will get strained and the water will pass through. So, that way the suspended impurities can be removed through the process of filtration. There will be hydrolysis which can take place. So, there is water, there are microbial consortia also present, microorganisms present in the soil. So, biotic or abiotic hydrolysis is also a possibility in this wetland system. There are biodegradation that takes place. So, wastewater will have organic and soil will have its inherent microorganisms. So, those biological systems will actually will go for the decomposition and degradation of the organic matter present in the wastewater. So, there will be biodegradation, there is a possibility of bioaccumulation. So, what happens that the plant is another essential component of the wetland systems. We can go for some specific species of plants or grass, those kind of things are there. So, we can pick those plants which have a higher capacity of bioaccumulation. So, various metals present in the water or various other things can actually be uptaken by the plants and can be stored in their roots or stems. So, that is what is actually the bioaccumulation. It leaves the water phase and get accumulated in these plant systems. There is phytoremediation. So, degradation with the plant or these species, and there is possibility of photoremediation as well, because if it is exposed to the atmosphere, so there is sunlight coming in, and those constituents which are susceptible to photodegradation will actually undergo. So, and that is how we can have some degree of photoremediation as well. So, all these are the processes which could possibly take place. It is not that these will definitely take place, but there is a possibility of these processes happening to variable degrees. Some may be dominant, some may have very little contribution. Apart from these also, there is a possibility of few more processes that could happen depending on the conditions of the wetland. So, if we see the various pollutant removal mechanisms in the wetland, okay. So, what happens that as the water it will pass through, there will be filtration and adsorption, as we were discussing, okay, on the sediments particularly. There is a possibility of volatilization, the wastewater, let us say if it is coming. So, there is a possibility of some pollutant may get volatilized as they get exposed to the nature. Okay. There is a plant metabolism, okay, that can also take place. So, the plant can metabolize what we were calling the phytoremediation, that can also takes place, the metabolism through the plant or those kind of thing. There is a possibility of bacterial degradation, there is a possibility of sedimentation, precipitation, adsorption. So, all those things will happen, and if we see the different constituents and how they remove. So, suspended solids will be removed either through sedimentation or filtration. So, either they will settle, get sedimented in the bottom of the wetland, or they will be filtered out. The soluble organics through aerobic or anaerobic microbial degradation. Okay. Of course, phytoremediation and those kind of things also could remove some of these. This phosphorus will be matrix sorption or the plant uptake. So, either they get adsorbed in the soil mineral matrix or uptaken by the plant. Nitrogen will be removed by the ammonification, followed by the microbial nitrification, denitrification, plant uptake, matrix adsorption or ammonia volatilization can also take place. The metals through adsorption and cation exchange system. So, if we are having, let us say some minerals which can have the exchangeability, so ion exchange can also actually be effective in this. Then complexation, precipitation, plant uptake, and microbial oxidation or reduction, and pathogens can be removed by sedimentation, filtration, natural die off. So, their natural decay process, their predation, UV radiation, if we can have those kind of systems present. So, these are the various mechanisms through which we can get the removal of these contaminants from the wetland systems. So, that way if you see, these processes are essentially the same that we discussed, but they takes place in a kind of environment which is created differently, which is packed in differently other than the typical conventional systems. So, the artificial wetlands, constructed wetlands, if we see, they are kind of designed to operate the processes that occur in natural wetland systems in a more controlled fashion. So, that is what is the idea or objective of putting through a constructed wetland system. As we were saying that in natural wetland systems, we do not have too much of control over the processes which we can achieve in the constructed wetland system. So, that is how the constructed wetland systems are more kind of popular for the wastewater treatment. Okay. So, this eventually allows the establishment of this treatment facility with well defined composition of substrate, type of vegetation and flow pattern. So, substrate essentially means media, it is not, it does not, like usually when we are talking about the biodegradation, we used substrate in terms of the BOD, okay, but here in the wetland system substrate we mean to say the media. So, what kind of media we are providing. So, and the BOD or the organic matter will always be there present in the water, wastewater which is coming into the system. So, we can have kind of a fixed composition, like what kind of aquatic plants we want, what kind of vegetation we want, what kind of filter media or media we want, okay, what kind of flow pattern we want, whether we want upflow, downflow or horizontal flow. So, all those things we can control. We can control these hydraulic pathways and the retention time, okay. So, for how long we want to the water to be retained in the system, that is also important, because if we are working with a very high flow rate, the retention time is very low. So, probably we will not be able to get the desired removal. In order to get the removal, we must ensure that the adequate amount, the water is spending adequate amount of the time in this wetland, so that those processes of sedimentation, process of degradation, decomposition or adsorption can take place effectively. Additional thing that does is actually the constructed wetlands also provide flexibility in site selection, because natural wetlands have the fixed sites where they exist, but constructed wetland you can create anywhere, even in a urban setup you can create a constructed wetland. So, that way we get the flexibility in site selection where we want to create that these things, and sizing also, to what size we want to create. Okay, what are the dimension we want to keep depending on the area, land area requirement, depending on the flow requirements, we can actually set up the size and set up kind of identify the appropriate location for constructing these wetlands. So, that is the advantages of kind of constructed or artificial wetlands, which gives us much more flexibility in operation, in design, in construction, in management and in process control as well. So, if we see the different components of a constructed wetland, okay, so there are kind of various components. There is substrate, which is, as we said, is actually the media, what media we are putting at the bottom. So, that is your substrate. Then there is a vegetation, what type of vegetation you want to provide, okay. So, that is another major component, what type of plant you are planning to grow, because these different plants have different characteristics. There are certain plant species which can actually have higher nutrient uptake, there are certain which do not need that much of nutrient to grow, there are certain plant species which have ability to uptake various heavy metals in their root zones and bioaccumulate them. So, if your idea is to removal of these kind of metals, you must go for those plant species. So, these the kind of vegetation will also give us an idea, or will give a kind of control over the performance of the entire wetland system, okay. So, that is a very important component, vegetation also. Then we have to have a kind of inlet and outlet arrangement, okay. So, how the water is entering, how the water is leaving from the system. So, that also will govern the kind of flow pattern that we are generating, okay. There has to be a liner, okay, that is another essential component, because we do not want our water to say percolate to the subsurface through these wetland treatment systems, particularly the constructed wetland treatment systems, because we want to get the treated water. So, for that purpose we would and there are a lot of pollutants also getting absorbed in this, and if that water leaches through, so that may actually get the, like those pollutants can also leach through. So, that for preventing that, for protecting that, we provide a liner, okay. So, the liner has to kind of ensure that there is no flow from this wetland apart from the direction which is intended to in the outlet system, okay. So, the flow has to basically come through inlet and leave through outlet and should not go in any other direction. So, that is another idea of providing liner, okay. And as we said that we will be having inlet and outlet arrangement. Then we may need under drainage system, that is not an essential component, depending on the design of wetland. If we are having a, say, if we want to collect the flow, particularly a vertical flow system where we want to collect the flow at the bottom, so we should have an under drainage system which collects the flow well and put it through outlet system. But in surface flow wetland or those kind of systems, we will not need this under drainage system. So, that becomes a kind of optional step, whether to like go for under drainage systems, or whether there is a requirement of under drainage system in that wetland or not. And overall these entire things has to be encased in a basin which actually gives you the boundary of the wetland system. Okay. So, that is another component, this overall basin under which all these things are kind of packed or arranged in the appropriate fashion. So, that is what is the various components of the wetland system. Again, the wetland could be of different type, that depends on their flow regime, that depends on their kind of how they have been constructed. So, there are surface flow wetlands and there are subsurface flow wetland. The surface flow wetland can be with emergent plant, submerged plant, free floating plant, floating level plants, that way. The subsurface flow wetlands can have horizontal subsurface flow or vertical subsurface flow. Then under vertical also we can have downflow, upflow or tidal flow, and we can have a hybrid systems where we can kind of mix more than one type of wetlands and in order to basically trying to extract the maximum feature of those things. Okay. So, if we see again there, like we may go for aerated wetlands, so artificially aerated wetlands or kind of drop aerated wetlands. There is a buffel flow wetlands where the flow is channelized in the buffled fashion. There is a step feeding wetland, so it goes to first step and then it goes to the second step, through flow it goes to the second step. So, that way there is a hybrid wetland systems, there is a circular flow corridor wetland system. So, it actually flows from one basin to another basin that way. Okay. So, there could be like variety of arrangements for kind of conceptualizing the wetlands, how we basically what kind of flow, what kind of processes we want to take place in our wetland system. The popular ones are the free surface wetlands, where which is very close to a kind of naturally occurring wetland system or natural wetland systems. Okay. Typical marsh or swamps, those kind of things. So, they replicate those cases only. We will have the substrate or media over at the bottom. Okay. The water will be put through the top, there is some sludge accumulation takes place through the settling, and the major water flows through the top itself. So, the degree of removal will not be too much in these free surface wetlands, okay, because this process of passing through the media is limited only, remains optional in fact at times. There will be plant uptake though. So, these whatsoever plant, those nutrients and those things can be taken off, the settlement, this kind of settling can take place, adsorption to some extent can take place, but again overall the removal efficiency will be lesser if it is just if it is just free water surface or surface flow wetland systems. Okay. And that is why these are generally not used for treating raw wastewater as a whole, rather they are used for either primary or secondary treated wastewater as a polishing unit or as a kind of next stage, tertiary stage treatment also they may be used. Then we have vertical flow wetland systems. Okay. So, these vertical flow wetland systems are we kind of, as the name itself suggests, the flow pattern or flow regime in the wetland is vertical. So, we will have influent coming in and they are released from the top, and from there this flow takes place to the bottom. In the bottom we have a drainage pipe or under drainage system, you can say that. Over and there is a gravel, there is a media or substrate. So, when they pass through these, there is adsorption takes place, then there are roots which will be like plant uptake or phytodegradation, then biodegradation will take place here, it goes to a gravel media. So, filtration, adsorption, all those processes will take place and eventually they will collected in the drain pipe and will come out of the system. Okay. So, that is what happens. Okay. So, that is the idea of a kind of vertical flow system where flow is the downflow. We have vertical flow upflow system also, where things remains more or less similar, only thing is that the water is released at the bottom and collected from the top. So, what happens then when you release the water at the bottom, so the direction of flow is reversed in that case, the direction of flow will be reversed in that case. So, you are having a wetland of this kind. So, water is coming in here, will being released from here, and through this there will be basically plants over there, and the media, these things will be there. So, water eventually takes a path upflow, and then the overflow goes from this point forwards. Okay. So, that is how the upflow wetland system will be there. Okay. Then we have another wetland, which is your horizontal subsurface flow wetland system. So, here as in the upflow or downflow, we are making water move either from up to down, or from down, like from up top to the bottom, or from bottom to the top. But in the horizontal subsurface flow wetland system, the inlet is released here only, and then there will be kind of substrate or media provided here, and then there is again media here. So, it flow, there is some down gradient slope in order to ensure the movement of water. So, net direction of movement of water will be this, it flows horizontally, and then as it flows through this media, so there would be kind of adsorption, all those processes will be taking place in this zone, the plant uptake, degradation, decomposition, and again it passes through a filter media, and then it is collected in the form of outlet. Okay. So, that is what happens, okay, in a horizontal subsurface flow wetland. And then we can have hybrid wetland systems as well. So, the hybrid wetland systems, as we are saying, that is actually a mixture of these different type of wetland system. So, the different type of constructed wetland can be combined to achieve a higher treatment efficiency using the advantages of these different individual systems. So, most hybrid constructed wetlands combined vertical filter and horizontal filter stages. So, there will be one stage vertical filtration, one stage horizontal filtration, at least that will be there, and we can have additional kind of setups or additional units as well. So, if we see the design configurations of these wetlands, various wetland systems. So, this for the purpose of design, we must think of the various life form of the dominating plant species which are there. So, microphytes, whether they are free floating, emergent, submerged, what kind of microphytes we are using. There are flow patterns, so free water surface flow, or the subsurface flow, or the horizontal flow, vertical flow, what kind of flow it is there. Then the type of configurations, whether it is hybrid system, one stage system, multi stage systems, what kind of wastewater is to be treated, whether it is simple domestic sewage or some industrial sewage, whether it is coming with the what level of the wastewater it is treating, whether it is treating primary level, secondary level, or tertiary level wastewater treatment, are there any pre-treatment has been provided or not, what are the influent and effluent structure final. So, whether it is just being dropped through a pipe or first it is being passed through a media. So, those kind of thing. What are the types of substrate or types of the kind of media. So, they are gravel, soil, sand, or any engineered media is also kept or mixed or amalgamated with that. The type of loading, whether it is a continuous flow wetland or intermittent flow wetland. So, whether it is basically continuously receiving the wastewater or wastewater is being loaded in the batches. So, that all those things need to be kind of seen for the purpose of designing. So, if we see the advantages and disadvantages, so wetlands can be less expensive to build than other treatment options. So, their cost is very low, the major cost is of land only. Okay, so that is the major component of the wetland cost. Otherwise, the construction is simple, they utilizes mostly the natural processes. Okay, it can be constructed with various local materials. The operation and maintenance is also quite simple, not much control is needed that way. Okay, and that why means overall they are quite cost effective process, and the process is also more or less stable. On the disadvantages or limitation front, there is a large area required. So, that is one of the major limitation of wetland system. Okay, particularly in the urban setups where a huge amount of wastewater is generated or industrial flow is generated, the land costs are quite high, and it is not possible to get a large land area which you can actually devote just for the purpose of wetland based wastewater treatment. So that will because if you plan to use just leave this large area for this purpose in a heart of a city or in the middle of say populated city, so that land cost is itself very high, and that land can be utilized for much better resources or much better purpose. That is one of the disadvantages. For small setups, that's like if there are smaller flows or rural areas or those kind of small towns, it is easier to get the area, and you do not need you do not have that much of technical supervision available. So these kind of systems could actually be ideal, okay, because they do not need those kind of technical expertise. So you can install these, they will operate pretty fine, but in a kind of urban setups, managing that much of area becomes very difficult. So it may be economical relative to other treatment options, but only where land is kind of available and affordable, and the design criteria has yet to be developed for the different type of wastewater and climates, because climate also plays a role in the treatment processes. Many of these are temperature dependent, your adsorption process, degradation process, bacterial growth. So particularly in the low temperatures, you may not get a very good efficiency through these wetland systems. So there are a variety of wetlands, like various wetlands has been installed across the globes, okay, all nations will have. India also, there are quite a few wetland systems are there. So for further reading, you can actually refer to these manuals and books, okay. So they are all available, most of these are in fact available online. So there is a constructed wetland manual, there is a handbook of constructed wetland manual, there is a EPA manual on the constructed wetland treatment of the municipal wastewater. This has various case studies combined, so some, as I think some 17 case studies are listed here, and there is lot of material available on the web on these wetlands. So for further reading, you can actually refer to these. So we will conclude this lecture here, okay, and in the next class for this week, we will be taking the other processes, recent or real, like the other wastewater treatment processes. So next class we will be talking about sequential batch reactor SBR, and it is another modification SBBR, sequential batch biofilm reactor. So thank you for being with us, and then see you in the next class.